Okay, folks, here we are. We finally made it to the last section of Chapter A and P. This is Section 8.3, Fractional Expressions. So remember when I said we needed to know how to factor? Boom, this is it. This is why. This and, things that come along in the future of the course, but this material right here requires you to be pretty good at factoring. So everything we do will be a fraction. Eek, scary, right? No big deal, okay? No big deal. First one we've been told to do is, or the first thing we've been told to do is to write this in its reduced form. I hate sideways fractions, so I'll start by writing it as a stacked fraction. And what we're going to be doing is factoring the top and bottom of this thing independent of one another. And then we'll go from there. All right, so we go ahead and we look at the top of this. And remember, when you're factoring, the very first thing you should be on the hunt for is a GCF. Well, you have one here. These two terms can both give up an x, so I'm going to pull that x to the front. Remember, pulling a GCF is a type of division, so pulling an x from these two things is going to give me x minus 3. Now on the bottom, this is the difference of two squares. We talked about this in the last lesson, so I'm just going to remind you of the formula. Anytime you see perfect square minus perfect square, you can instantly factor it into a pair of conjugates. A plus b times a minus b, where a and b are the square roots of the front and the back. So what we're going to have here is the square root of x squared of 9, 3. So we have x plus 3 times x minus 3. There. Now anytime you have an identical term on the top and bottom of a fraction, when everything's separated by multiplication, which these are, there's a multiplication dot there and there's a multiplication dot there. Again, you can only do this when things are separated by multiplication dots. If you have something that's the same on the top and bottom, it's going to cancel out. So these x minus 3's, they cancel out. And our expression will simplify to x over x plus 3. But that is not the complete answer. Why, Mr. Ryan? Well, here's why. You have knowledge of what this question originally looked like. You have knowledge of the fact that this denominator used to have two numbers that made the bottom equal 0. Negative 3 made it equal 0 on the bottom. Positive 3 made it equal 0 on the bottom. And you are never allowed to have a 0 on the bottom of a fraction. So because you have the prior knowledge that there were two numbers that x couldn't be, you know that at the end there must still be two numbers that x can't be. X still can't be negative 3, which this shows me. X still can't be positive 3. This doesn't show me that anymore, so I have to say it. X cannot be positive 3. Because until you say that, these two things are not exactly equal to each other. Now they are. There it is. So basically, if you're going to cancel something off of the bottom of a fraction, you must represent its 0 in your final solution. I'm not quite sure if you heard my son in the background. Might be worth a little bit of comedic relief. All right, so this kid. And we're back. That was quite the interesting fiasco. Oh boy. Okay, anyway. I think we were about to do some mathematics a minute ago. Well, it was a minute for me. It was fast for you guys because I was able to pause the video. But anyway, multiplying and dividing rational expressions. As long as you can factor, this is a pretty simple skill. You're just going to factor whatever you can and cancel wherever you can. Pretty simple for multiplication. So let's see. This first one, 2x plus 4, it does have a GCF. Both of these terms are even, so I can take a 2 from both of them. X minus 1, that one's stuck. Times. All right. Oh boy, check it out. A quadratic with a number in front of x squared that is not a 1. We're going to have to tackle this using the Lizzie method. I'm going to put a little piece of paper underneath my notes here so my pen stops scratching the wood table. Alrighty, Lizzie method for this one. looking for the two numbers that will multiply to a times c, which is 2 times -3 or -6. I need those two numbers that multiply to -6 to add to my b value of +1. The two numbers that multiply to -6 and +1 are 3 and -2. So we come over here and we say two sets of parentheses, x in the front of both of them, and the numbers 3 and -2 in our parentheses, so +3 over, -2 over, and please don't forget this step, over A2. All right, well, while we're here, before we go finishing what's going on up here by reducing this fraction, let's take a look down here. Well, there's a GCF here, and let's see, 6, 36, and 48. Looks to me like all of those numbers are divisible by 6. Okay, well that's good news, because that means that this quadratic is only going to have an x squared on the front, so it'll be easier to factor. So 36 divided by 6 is 6, and 48 divided by 6 is 8. So for that one, we're just going to be looking for the two numbers that multiply to 8 that will add to 6. This one would not require that whole Lizzie method step of dividing by a, because a is 1, so it's not going to change anything. I mean, you're welcome to do it, but it's not going to change anything. The two numbers that multiply to 8 that add to 6 are 2 and 4. So I'll continue working in purple. This space has been taken up, so I'm just going to have to scoot down, run it a little low on vertical and horizontal space here. I've got a 2, an x plus 2, an x minus 1. Now on the top of this fraction, remember, any fraction that can simplify, you do, and any fraction that does not simplify, you take the number that's left on the bottom of the fraction and move it in front of x. So this first set of parentheses becomes 2x plus 3. And the last one is just going to be x minus 1. Down here, here's our 6. Don't lose that 6. And we said that this quadratic is going to use the numbers 2 and 4 in its parentheses. So x plus 2, x plus 4. Now because we're multiplying fractions, it's very, very easy. You legitimately multiply across the top, multiply across the bottom. So you can actually imagine that all of this is one big fraction. You know what? Watch this happen. Boom. Now it's one big fraction, all of this stuff on the bottom, all of this stuff on the top. And just like we did in our very first example, anything that exists in the top and the bottom, as long as it's separated by multiplication, and all of this is separated by multiplication, big space there, get fat math, anything that exists on the top and the bottom will cancel out. So what we got? I see an x minus 1 on the top and bottom. I just canceled an x off the bottom. I'm going to have to write a number x can't be. I see an x plus 2 on the top and bottom. I just canceled another number off the bottom of this fraction, or another term, excuse me, specifically an x. So now I know there's going to be two numbers that I have to say x can't be. And lastly, it's not going to make us write anything special, but 2 and 6 can both be divided by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. So this thing finishes up as just a 2x plus 3 on top, and on the bottom, a 3 and x plus 4. And there will be two numbers that we have to say x can't be. And once again, the reason why we're doing that is because we have prior knowledge. We know that when this question began, x couldn't be positive 1, and because of this, it couldn't be negative 2 or negative 4. But in my final result, all I know is that x can't be negative 4. But these things are supposedly equal. I mean, look at all the equal signs. They're supposedly identical. So the only way they're going to be identical is if I list the two numbers that x can't be that I eliminated. X cannot be positive 1, x cannot be negative 2, and now they are identical. Okay, so for this one, you had two options. You could either start factoring things, or you could deal with this pesky division symbol. I'm going to go ahead and deal with the pesky division symbol first. Whenever you are dividing by a fraction, you're actually going to be multiplying by the reciprocal. Your teacher in the past might have called this the whole keep change flip, or KFC, keep flip change, or something like that. Basically, it means don't do anything to that first fraction. Change the division to a multiplication, and then flip the second fraction over. This is where you would want to start factoring things. Well, these are both going to be the easy Lizzie, easy Lizzie, because there is no number in front of x squared. So for this one here, we're looking for the two numbers that will multiply to negative 20 and add to negative 1. All right, the two numbers that multiply to negative 20 that add to negative 1. And by the way, I'm not shaking. The table is grooved. Sorry. Anyway, the two numbers that multiply to negative 20 and add to negative 1 are negative 5 and positive 4. So that's what this quadratic is going to break down to. And let's go ahead and tackle this one. We're looking for the two numbers that will multiply to negative 12. And we'll also add to negative 1. That's going to be negative 4 and 3. All right, back to our fractions. This first one we said is going to be x minus 5, x plus 4. Below it is going to be x minus 4, x plus 3. This numerator has a GCF of 4, so we divide a 4 out. It leaves behind an x minus 3, because remember, pulling a GCF is division. And on the bottom, I still have this 8. Now, just like we did before, because we are multiplying fractions, we go across the top and we go across the bottom. What that means is we can legitimately just do this. We make it one big fraction and then just go, oh yeah, but all this stuff is strung together with multiplication dots. And we would want to do that because now we can cross off terms that exist on the top and the bottom. Let's see what's going on. Minus 5 doesn't exist. Plus 4 doesn't exist. Minus 3 doesn't exist. Huh. How about that? Well, the 4 and the 8 reduce, but Mr. M, these are so similar. And these are so similar. Yeah, I know they're similar, but they're not identical. And because they're not identical, we can't cross anything off. Legitimately, the only thing we could do is reduce this 4 over 8. And both the 4 and the 8 can be divided by 4. Dividing this by 4 gives me 1, and dividing this by 4 gives me 2. All that's left to do is write this as one fraction. On top, and order doesn't matter, I'm just going to be extra, and I'm going to write them in numeric order. X minus 3, x plus 4, x minus 5. And on the bottom, there is a 2. Generally, our coefficients belong in the front. X plus 3 and x minus 4. And that's it. You see, I don't need to mention any numbers that x can't be because I never eliminated anything from, or any x's from the denominator. And because I never eliminated any x's from the denominator, we're in good shape here. This was not an x. This was simply me reducing a fraction. There you go. Multiplying and dividing rational expressions is actually one of the easiest things you can do. Now adding and subtracting, not as simple. Why? Well, pretend that these x's weren't here. 2x over 3 and 2 over 5. You can't just subtract straight across there, because the only time you can add or subtract fractions is when you have the same denominator. So we're going to be on the hunt for the least common denominator. Let me tell you how you can never find a least common denominator. You can never find a least common denominator by adding to the top and bottom of a fraction. Think about it. Every time you've ever found a least common denominator between two numbers, what you've done is you've multiplied to the top and bottom of a fraction. Those rules never change. I don't care that it looks like you should just be able to add 2 to the bottom of this and it would match this. You're not allowed to do that. Adding 2 to the top and bottom of a fraction changes the value of that fraction. But multiplying by a number on the top and bottom does not change the value, because that's the same thing as multiplying by 1. So then how do we make this happen? How do we tackle this? Well, if there were things to factor, you would factor them, and you would look for common factors. But this one doesn't have anything that factors. So what you do is you treat x plus 3 as 1 unit and x plus 5 as 1 unit. And you realize that in order for these two things to have a common denominator, it's going to have to be x plus 3 and x plus 5. That means, oops, I hit my paper. That means this fraction must be multiplied by x plus 3 on the top and bottom. And this fraction must be multiplied by x plus 5 on the top and bottom. Let's see if I can squeeze it in there. Yeah. There we go. I am going to clean it up a little bit. Yeah, I'm going to write this one in green. Okay. Multiplication doesn't care about order, so I'm going to put that 2x in front of this x plus 5. There's a minus sign there. Minus 2 times x plus 3. And our common denominator now would be x plus 3, x plus 5. Order doesn't matter. Oh, Mr. M, can't I just cancel out these x plus 3s and these x plus 5s? No, you can't. But why? Because these two terms are not separated by multiplication. You can only cancel from the top and the bottom when things are separated by multiplication. This negative sign right here stops you from doing any kind of canceling. So what do we do? You distribute on top and combine like terms. This 2x distributed to the x, and this 2x distributed to the 5. Be very, very careful. The symbol in front of a number belongs to that number. This is not a 2. This is a negative 2. You will be distributing a negative 2 to this x and this 3. And if you forget and you distribute just a 2, you will find your wrong answer on my test. Not because I'm mean, but because it tells me exactly what it is that you're doing wrong. See the grooves? Told you. Anyway, distributing 2x to x gives me 2x squared. 2x to positive 5 gives me 10x. Negative 2 to x, negative 2x. Negative 2 to 3, negative 6. On the bottom, do not FOIL. Leave it factored. The reason why we leave it factored is because, well, it would make it easier to graph if I was making us do that. Also, it shows us the two numbers that x cannot be. Also, and finally, the hope is that something up here is going to clean up really well, and then we could factor it and then cancel something. So let's see what we get. 10x minus 2x is 8x. You know what, folks? We might be in luck. We might be in luck. Something else might factor and cancel. What I see on the top here is all three terms are even. So there is a GCF of 2. I could pull that 2 to the front. X squared plus 4x minus 3. So are there two numbers that multiply to -3 that add to 4? No. No, there's not. Okay. So that does not factor. And because I didn't cancel anything off of the top and the bottom down here at this bottom corner of the page, I don't have to mention any numbers that x can't be. And that's it for that question. So we'll flip it over and head to the back. And, oh, okay, look at that. We have another adding and subtracting rational expressions question. So the only reason why I would have given you another example is if this one shows you something that the last one didn't. Let's see if that's the case or if I'm just losing my mind. Oh, no, here it is. Look, this denominator factors. This is the difference of two squares, just like we saw in the very first example of today's notes. Yeah, right there. Anytime you have perfect square minus perfect square, you end up with the product of two conjugates. Pick a good color. I like blue. Blue's feeling good today. We have a 9 over two sets of parentheses. They are going to be conjugates. Square root of x squared in the front of each of them. Square root of 1 in the back of each one of them. Each of them, 1 is plus, 1 is minus. There you go. And then over here, there is nothing to factor. Mr. M, can I cancel these x's? No, you can't. This plus sign is stopping you because these terms are not separative by multiplication. There is no canceling stuff from the top and the bottom. Don't try to do it. So what we need now is a least common denominator. What I'd like you to see is that this denominator is already made up of two pieces. It's made up of an x plus 1 and an x minus 1. This denominator is made up of a single piece, x plus 1. So the only thing I have to do to achieve the same denominator on both of these fractions is to end up with an x minus 1 right here. And since we're going to be doing that through multiplication, that is how we find our least common denominator. We will multiply the top and bottom by x minus 1. This gives us the ability to write it all as one fraction with this as the denominator. So I have 9 plus 2x times x minus 1 over x plus 1, x minus 1. Mr. M, can I? No, don't even try. What you can do, though, is you can distribute this 2x. And it's positive this time, so no worries, nothing tricky going on there. 9 plus 2x squared minus 2x all over x plus 1 times x minus 1. This numerator is written odd. It's not in standard form. Standard form would have it written in the correct order. So I'm just going to reorder it real quick. 2x squared minus 2x plus 9, because this 9 is positive, all over x plus 1 times x minus 1. Again, the hope would be that this quadratic up top factors, and maybe we'll get lucky and cancel something out. So this would require our Lizzie method, where we have to figure out two numbers that multiply to a times c. So two numbers that multiply to 18, and we would need those two numbers to add to -2. That's impossible. So this doesn't factor. And since I didn't have to cross anything off the bottom anywhere, I also don't have to mention any numbers that x can't be right here next to it. So this question is finished. Uh-oh, 3 fractions. Scary! It's not a big deal. All we're going to do is factor everything that can factor. We'll start there. The first fraction, its denominator does factor. Both of these terms can give up an x, and that will leave behind an x minus 2. And I'm just going to draw your attention to the fact that these are separated by multiplication. That means that denominator has 2 pieces. Our next fraction is simply 1 over x. All right. This fraction only has one thing in its denominator. It has an x. So does this one. That means this fraction, it just needs an x minus 2 to match. But before we get to that, let's see what's going on with this next fraction. Oh, look, a perfect square minus a perfect square. That is an a squared minus b squared situation, so it instantly factors to square root of the front plus square root of the back times square root of the front minus square root of the back. A product of two conjugates. And there we go. This denominator has two things in it as well. So what we need to do is we need to figure out what all of the individual unique denominator pieces are. So basically what you do is you start listing them and you don't repeat anything unless it's in one denominator more than one time. What do I mean by that? I mean, like, let's say this one had an x minus 2, and this wasn't a plus. Then you'd be forced to say it twice because it existed in one denominator twice. But we don't have that case. So what do we have? One of our denominators is x. One of our denominators is x minus 2. I've already said x. I don't need to say it again. X plus 2. That's a new one. I don't need to see x minus 2. Okay, so my least common denominator consists of three things. Those three things are x, x minus 2, x plus 2. Cool. That means this one just needs an x plus 2. This one needs the x plus 2 and the x minus 2. And this denominator has the x plus 2, it has the x minus 2, it doesn't have an x, so we'll just throw an x on the top and bottom. Time to clean it up a little bit because got a little cramped, especially right down there. Let's see what we get. Right here, I'm going to distribute a 2. 2x plus 4. Right here, I'm distributing a 1. And, well, that's not going to change anything. So we just need to know, what does x plus 2 times x minus 2 give us? Well, it gives us that. I mean, that's where those things came from, right? So this x plus 2, x minus 2 has to equal what this one does, which is x squared minus 4. And then right here, there is a minus 3x. And all of that is over x times x plus 2 times x minus 2. Now, if you're sitting there wondering where did all the other denominators go, realize they didn't go anywhere. What is 1/5 plus 2/5? It's 3/5. You see how you don't repeat the denominator? This is the same exact concept, it's just that our denominators are made up of x's and numbers, not just numbers. But the concept still remains the same. Let's combine our like terms. Leading coefficient is, leading term is going to be the biggest exponent, so x squared. Now let's look to our x terms. There's 2x minus 3x, minus x. And our constants are 4 and negative 4. Oh, those cancel out, don't they? Cool. Just like before, we need to see if this numerator factors. And you know what? This one does. This numerator factors, it has a GCF. Both of these two terms could give up an x. Let's pull that x to the front, leaving behind an x minus 1. And remember, when everything is separated by multiplication on the top and bottom, a term that exists in both places can be canceled out. So this x can be canceled off the top and the bottom. But since I had to cancel an x off the bottom, I must mention a number that x cannot equal. And that would be whatever made the canceled thing equal 0 down there. This is an x. The only thing that makes it equal 0 is 0. So x cannot be 0. Whew, it's quite the mental exercise right there. And our last concept of chapter A and P, the compound fraction. This is fractions within fractions. It's like the pimp my ride of mathematics. We heard that you like fractions, so we put fractions in your fractions. My wife, I'm not sure if she thinks that joke is funny or if she thinks I'm so corny. Regardless, she's laughing. That's why I said I don't need you guys to laugh at my jokes. I'm married. She will humor me. Okay. Anyway, what are we going to do? What we're going to do is we're going to pretend we don't see this stuff down here. And we're going to go, all right, my job is to find the least common denominator and combine those two fractions. And then we're going to do the same thing here. We're going to pretend we don't see that stuff on top. We're going to go, oh, I need to find the least common denominator and combine those two fractions. We just have to handle them separately from one another. So focusing on the top only. This denominator is a 2. This denominator is an x. If only this one had an x, and if only this one had a 2, they would match. So that's what you do. You do x on the top and bottom of that one, and times 2 on the top and bottom of that one. Now we look at the bottom fractions. This one's denominator is a single x. This one's denominator is a pair of x's that are being multiplied to each other. Well, this can easily become a pair of x's. I just have to multiply the top and bottom by x. There you go. Let's see what happens. Okay, so what's going on the top is x times x, which is x squared, minus, because there's your minus sign, 2 times 2, which is 4. All over, well, just 2x. Down here, you get x minus 2 all over x squared. So what's happening here? What's happening here is you have a fraction that is being divided by, because remember that's what fraction bars mean, a fraction divided by another fraction. And I mentioned this earlier, that when you divide by a fraction, you do that whole keep, change, flip deal, where you turn the division into multiplication and you flip over the other fraction. This will be the resulting operation. X squared minus 4 over 2x times, now we flip this one over, x squared over x minus 2. Now it looks just like one of the questions that we did on the front side here, where we were multiplying rational expressions. The process stays the same. Factor anything that can factor, and there it is again. It must be pretty super important since I keep bringing it up. The difference of two squares, perfect square minus perfect square, instantly factors to a pair of conjugates. Square root plus square root minus square root. Square root of x squared plus the square root of 4 times square root of x squared minus the square root of 4. And that's the only thing that factors. But because it is multiplying these two fractions, that's straight across the top, straight across the bottom, we could just say, yep, it's all there. Just like that. We'll put that in parentheses. There's a multiplication dot. There's a multiplication dot. And since everything's separated by multiplication, we hunt for things that existed on the top and the bottom so we can cancel them out. And I see one right there. And you know what else? I have x's on the top and the bottom. So these x's down here are gone. Think of this as saying x times x. This was a pair of x's. If you take one away, you have a single x. So I like to just do this. I didn't take any square roots or anything. I just took away one of the two x's, so there's only one left. The final result is x times x plus 2 divided by 2. And you took two different x's off the bottom of this fraction, which means you have to mention two different numbers that x is not allowed to be. For this one, the only thing that would have made 2 times x equal 0 was if x was 0. And for this one, the only thing that would have made x minus 2 equal 0 is if x was 2. And there you have it, compound fractions.